In this video, we are going to talk about boiler water and steam condensate corrosion. So first is always description of damage. So general corrosion and pitting in the boiler and the condensate return system, it is primarily a result of dissolved oxygen or carbon dioxide, which could lead to oxygen pitting corrosion or carbonic acid corrosion respectively. Flow accelerated corrosion in the system may occur either as general wall thinning or localized corrosion at high velocity, high turbulence and change of flow directions. So this kind of corrosion generally has an appearance which is very common to erosion corrosion. So wherever there is a high velocity flow, wherever the flow is changing its direction, and that area you will see localized thinning or general thinning, which will have very deep grooves associated with it. So we'll talk about this when I show you the picture, but it will have grooves associated with it in the direction of the flow. What kinds of equipments are affected? So affected equipment are general materials, which are carbon steel and low alloy steels. Critical factors. So critical factors are concentration of the dissolved gases, that is either oxygen or either carbon dioxide, pH, temperature, quality of feed water, and specific feed water treating system. Corrosion protection in the boiler is accomplished by laying down and continuously maintaining a layer of protective magnetite, that is Fe3O4. In case of flow accelerated corrosion, the protective layer is dissolved or prevented from forming. Carbon steel is most affected. Allowing elements, so in carbon steel you generally not use carbon steel as it is, because some kinds of alloying elements are added to ensure that the corrosion protection happens. So alloying elements in carbon steel such as chromium, copper, molybdenum can enhance the corrosion resistance. The most critical temperature for flow accelerated corrosion is 150 degrees Celsius, and it decreases with increasing pH. So as your pH keeps increasing, so if at normal pH the critical temperature is 150 degrees Celsius, if your pH increases, then this temperature would come down. Okay. Too low an oxygen concentration increases the corrosion due to inability to form protective oxide layer, that is magnetite layer. At least 3 parts per billion to 7 parts per billion may be required to form an oxide layer. Chemical treatment of the scale and deposit control may be adjusted to coordinate with the oxygen scavenger for specific water treatment and boiler feed water treating system. Oxygen pitting can occur if the deaeration and oxygen scavenging equipment are not working correctly. Affected equipments. Corrosion can occur throughout the boiler water system, including deaerating equipments, feed water lines, pumps, as well as steam generation system, including stage heaters, economizer, boiler tubes, as well as process unit steam generators. Corrosion in the condensate return system, as well as in process unit boilers, reboilers, and associated piping may be due to carbon dioxide, although oxygen pitting from oxygen contamination is also possible, as well as flow accelerated corrosion if proper conditions are present. Threaded connections are specially susceptible. Appearance. So it will have pitting type of appearance, it will have groove-like appearance on the inner surface of the pipe or the equipment. So corrosion from oxygen is normally a pitting type damage. It can occur anywhere in the system there is in leakage of air, or even if only small quantities break through the oxygen scavenger treatment. The oxygen is particularly aggressive in the equipment such as closed heaters, economizer, where there is rapid water temperature rise. Carbon dioxide corrosion is normally smooth, but it can also cause grooving of the pipe wall. Corrosion may be localized at the area where the gases in the water are most concentrated, such as water to vapor interface level in the vertical reboiler. Flow accelerated failures are often located in the areas where the flow disturbance such as orifice run, flow meter, elbows, reducers and other types of fittings are installed. Wall thinning occurs just downstream of these flow disturbances, leaving behind a corroded surface free of oxide scale, sometimes with a specific flow pattern. Flow accelerated corrosion has led to rupture of the piping. So generally grooves would be generated on the inner surface of the piping, and the grooves will have extended tails towards the downstream of the flow. Prevention. Oxygen removal from the boiler feed water typically includes mechanical deaeration following by the scavenging with catalyzed sodium sulfite or hydrazine, depending on the system pressure level. Proper deaerator operation accurately controls scavenger chemical addition are important. A residual of oxygen scavenger is carried out to the steam generation system to handle any oxygen ingress beyond the deaerator. So anytime there is an oxygen, you can have this problem. Obviously, this would mean that we require no oxygen, but that is not true. We require some amount of oxygen to create an oxide layer, but if it goes beyond a permissible value, then this oxide layer will not be able to form and you will have this kind of corrosion. If the scale and deposit control of the magnetite maintenance treatment scheme do not minimize the carbon dioxide corrosion in the condensate return system, an amine inhibitor treatment might be required. Water treatment, sampling and analysis are most commonly used methods to ensure integrity and prevent the boiler water and condensate corrosion. It may be necessary to modify or improve water treatment program if problems such as rupture boiler tube or condensate leaks occur in the boiler water or condensate system. pH, temperature, oxygen concentration are main parameters that can affect potential for flow accelerated corrosion. Boiler feed water from pH 9.2 to 9.6 is often recommended. Upgrading the material to chrome moly steel usually solves this problem. Inspection, generally it is going to be wall loss. So wall loss can be identified by profile RT and UT. Generally you would not recommend MT or PT because this will generally happen on the inner surface, which in most cases not accessible. You can use visual testing provided if there is an access where you can go inside the system, or you can do remote VT. So monitoring the appropriate parameters can indicate whether the treatment program is performed satisfactorily. Parameters that can be controlled through analysis include pH, alkalinity, hardness, conductivity, chloride or residual biocide, dissolved gases, iron, copper and total dissolved salts. Vacuum testing can also be used to check for air ingress into the boiler condenser hot well. UT-RT can be used for identifying pipe thinning. For boilers, there is no practical online inspection methods. UT-RT can be performed on the boiler tubes when the boiler is offline. So it looks something like this, where you can see on the inner surface you are seeing pitting. So this would be a case of localized corrosion that is happening due to oxygen. And this will be because of carbon dioxide. In the direction of the flow you are seeing this orientation. Okay, so it's very common to understand, but it can be very confusing as well depending on what kind of corrosion you are seeing, because sometimes you might get confused that if it is due to erosion corrosion or due to boiler water condensate corrosion. But you have to understand this, that boiler water condensate corrosion will generally be associated with boilers only. If you don't have a boiler, then this kind of corrosion generally would not be visible. Okay, it can also be seen something like this. So this would also be considered as boiler water condensate corrosion, provided your system is working in a boiler environment. If it's not in a boiler environment, it might not be this, it might be something else. Okay, so that's it for this video. In the next video, we'll talk about some other damage mechanisms.